This time we're going to go ahead and do a complete integration problem start to finish using the substitution method. So this is our first example. Okay. So again, how we know that we want to use substitution is I have stuff in parentheses with the outside exponent and extra stuff outside. All right, what we're going to do is we're going to let u equal the stuff inside the parentheses. All right, so I'm going to let u equal, that pen doesn't work. Let's try that again. All right, u equal x squared plus 5. Okay, now you may be thinking, Jen, why did you go through all that trouble to get a different color? So here's the deal. What I like to tell students is imagine that you're doing a translation from French to Spanish. Well, we're doing a translation from X's to U's, okay? So right now what I have is I have a half translation. So what's going to happen is this is going to take the place of this. So what I have is I have 2x and a dx still left behind, but that middle stuff changed to a u to the 9th. So this is all u to the 9th. Okay. Well, I'm not done translating. Right now, it's like I have half French, half Spanish. I need it all in one language, and that all language that I'm trying to go to is a U. Okay, so this is where the most important step comes. We need to finish our translation, and how we finish it has to do with this relationship. Okay, so when I have u equals x squared plus 5, what that means is that if I took the derivative of u, the derivative of u here would be 2x. Okay. Well, when I do this, we're not going to write it in that notation. We're going to write it du dx. Okay. So the derivative of u with respect to x is 2x. Okay. Now, since I want to separate u's and x's, I'm going to move this dx to the other side. And what I get is du equals 2x dx. What this is how I'm going to negotiate my trade. So if you look back here, my integral was u to the 9th, and I had an extra 2x dx left to trade. Well, guess what? That's exactly what I have to trade. I can trade a 2x dx for a du. So what's going to happen is all of this is going to be a perfect trade and trade for du. So I'm going to get the integral of u to the 9th du. Okay, now what should happen is what we should be left with should be easy to integrate in u. So let's see if that's true. Can I do the power rule on this? Sure, add a 1 and then divide. So this would be u to the 10th over 10. Now, we are almost done, but do not call it good yet. Yes, we need to add a plus c, but more importantly, the original problem was in x's. So actually what I want to do is I'm going to replace this u by x squared plus 5. So I'm going to go x squared plus 5, because that's what u equals, to the 10th, divided by 10, plus c. All right, there's our first substitution problem done.